All right, we pick up with day 2 of the mean value theorem. We have a function 2 over x plus 3, and I'm going to zoom 6, zoom standard, check out this graph. And I want to look at the value of -2 and +4 and roughly see where this function is. So I'm going to just calculate a value, number 1, at -2, and you can see that it produces this portion of the graph right here. Is everybody clear? And then I'm going to calculate, so I can calculate value of number 4. Actually, I don't have to do that again. You can just simply type it in, and I get that spot right there. Now, what do you notice that's interesting about this function? Anything? It's got an asymptote. That's where it's undefined, correct? At what spot is it undefined? -3. Is -3 in this interval? No, it's not in the interval. So, is the function continuous and differentiable from -2 to 4? It is. And so, therefore, the mean value theorem applies. So just because you see a function that's not differentiable or not continuous at some point doesn't mean that the mean value theorem doesn't apply. It would have to occur over the interval. So we all in agreement that the mean value theorem applies. Great. If you can take the derivative, so the spots where you can't take the derivative are if you have a corner, if you have a vertical tangent, or if it's discontinuous. We all good? Okay, so I'm going to sketch just that portion of the graph. Oop, I did a bad job there, my bad. Let's see here. And really what we're doing is we are looking for kind of that blue section. Tell me about the average rate of change of that blue section. It's negative, so our slope should come up negative. Everybody good? So I'm going to use the mean value theorem to find a value c in the given interval that satisfies f prime of c is equal to the average rate of change. So the mean value theorem again is this. F of b minus f of a divided by b minus a is equal to f prime of c. Our goal is to find c. What two numbers must c be between? What the heck is f of b minus f of a over b minus a? It's the slope. It's the average rate of change. Katie said it's negative. She's absolutely right. So what we will do is we will determine f of b minus f of a over b minus a. So f of b, I'll plug in 4. And when you plug in 4, what do you get? 2 over 7. F of a. Uh, 2 over 1 is going to be 2. So therefore, we have 2/7 minus 2 over 4 minus -2. Two minus 7 would be, or 2 over 7 minus 2, that would be a 14 over 7. So we get -12 over 7 over 6. Multiply the top or multiply by the reciprocal, and I get -12 over 42. 12 and 42 are both divisible by 6. Divide them by 6, and we get -2 over 7. Does it appear that the slope, the average rate of change, would be approximately -2/7? Yep. Is everybody okay? So did I just do the left side or the right side of that formula? I just did the left side. So what the heck do I do now? Why do I take the derivative? because it says f prime of c. We'll take the derivative and we'll use that to find c. So negative 2/7, that's the left side. That's the f of b minus f of a over b minus a is equal to, I have to take the derivative. The derivative of 2 over x plus 3. What rule do you need to use? I don't like to use the quotient rule. So I'm going to use the chain rule. 2 times x plus 3 to the negative 1 power. What's the derivative of the inside? 1. The derivative of the outside, negative 2 times x plus 3 raised to the negative 2 power. Or negative 2 over x plus 3 quantity squared. Good with that? Okay. So that I have to solve. How would you like to solve that? Got a couple options. Cross multiply, like the idea. We get negative 2 times x plus 3 quantity squared is equal to negative 14. Now what? Divide by negative 2, I get x plus 3 quantity squared is equal to 7. Now what? Square root, so x plus 3 is equal to plus or minus the root of 7. So x is equal to negative 3 plus or minus the root of 7. We have to come up with a decimal there. Negative 3 plus the root of 7. And I get negative 0.3542. And then negative 3 minus the root of 7. And I get negative 5.65, or 6457. Okay. So which one is the one I want to use? Or do I want to use both? Why am I using the first one? Very good. I use this one because this one fits in the interval right here. Okay. Now, for the sake of brevity, yesterday we actually found an equation for a line tangent, didn't we? I'm not going to require that you do that on your assignment, and I won't require it the rest of the way for us. But that would be a great opportunity for us to check our answer. The reason why I first started doing that is I wanted people to understand what they were finding, what they were doing. So somebody tell me, what the heck does this negative 0.3542 mean? That's what? The x value of what? Of the tangent line. In fact, here's a great way where you could decide you want to check your answer. I'm looking at the graph. I'm going to compute the derivative. Second, calculate which one's the derivative up here. Number 6. And I'm going to compute the derivative at, I can even type it in exact. I can type it in at negative 3 plus the root of 7. And so it's going to find that spot on the graph, and it's going to compute the slope. And it says the slope is negative 0.2857143. Is that negative 2/7? It is. If you took negative 2 and divided by 7 on your calculator, negative 2 divided by 7, you'd find, sure enough, it is. So that's another way to verify your answer. Actually, I like that better. That's the first time I've done it during this lesson. We'll continue to do it the way through. See how I can verify your answer? Very good. Awesome. All right. I'm not going to ask you to write an equation for a tangent line. I find it to be redundant upon our part. I think you already know how to do it. Is that right? The answer is this guy right here. C is equal to negative 0.3542. Uh-oh, what about this? You hate sine, don't you? You just give up and run away. I like the way you think. Okay? Do we know what the graph looks like? It'd be kind of nice to sketch the graph, couldn't it? Let's think about this graph. 3 sine of x over 2. Let's think about the period. Do you remember how to find the period of a sine graph? 2 pi divided by b. What's your b value? 1/2. So if you take 2 pi divided by 1/2, what do you get? 4 pi. Period. How often does it repeat itself? Sine curve repeats itself every 2 pi units. So therefore, if you're dividing it by 1/2, 1/2 is the number in front of x, you get 4 pi. What's the amplitude of this sine graph? 3. So if I did a quick sketch of this graph, and I want to go from 0 to 3 pi, notice it repeats itself every 4 pi. So I'm going to divide it in half and in half again. I'll go up to 3. I'll go down to -3. Where does the sine graph start? Top, bottom, or middle? Middle. Very good. Where does it go? Up or down? Up, then back down, and back up. Right? So this is our sine graph. Is everybody okay with that? Expected to do what? Could you do it on your calculator? I do expect you know how to graph a sine graph. If you don't know how to do it, I would want you to come in and get help and go over that again. Yep. So we have 0 and we have 3 pi. Tell me about the average rate of change. It's negative. Okay, good. I would also like you to tell me, when my green pen gets to a spot where if I took the derivative, I would come out with a result that would be equal to the average rate of change. Anybody want to give it a shot? Be rated. So if you draw a tangent line there, it can be about the same slope. And tell me when to stop again. Is everybody convinced by looking at the graph that I should have 2 spots? No. I mean, it's a pretty rough sketch, and I know it's not very pretty, but can you see by just making that very basic sketch that I should come up with 2 C values in that interval? Is that clear to everybody? And here's where we fall apart. A lot of people are like, well, what do I do first, Mr. Gens? Do I do the graph, or do I find f of b and f of a and so on and so forth? I don't know. I chose to make the graph first because I think that gives me a great picture of what I'm going for. But I know some people hate graphs, so you got to decide which route you're going to go. So let's compute f of b and let's compute f of a. F of b, I plug in 3 pi. 3 pi divided by 2. Anybody know the sine of 3 pi over 2? -1 times 3, -3. If you just look at your graph, doesn't that tell you the answer as well, folks? Yeah. What's going to be the sine of 0? 0. Yeah. I mean, so our graph even tells us the answers right away. So I'm going to take f of b, -3, minus a, 0, and divide it by what? 3 pi minus 0. And I get -3 over 3 pi, which is -1 over pi. Just for the sake of trying to do a little bit of work here in the future, I'm going to take -1 divided by pi to get a little bit of a decimal. I get -0.318. What is that? What does that mean? Slope of what? Which line? Slope of all of them, right? But the average rate of change is really what I was looking for here, which is the blue one, okay? But it's going to be the same as the slope of the green ones because they're all parallel, right? They're going to be the same. So I just did the left side of the equation. So what do I do now for the right side of the equation? Ooh, I got to take the derivative of 3 sine of x over 2. What's the derivative of the inside? 1/2. What's the derivative of the outside? Yep, that's my derivative. 3/2 cosine of x over 2. I have to solve that. Do you remember how to solve trigonometric equations? I bet you know what to do first, though. I bet you know what I do to both sides right away. Divide by 3/2. We're multiplied by 2/3, so we go negative 0.318, and we're multiplied by 2/3, and I get negative 0.212 is equal to cosine of x over 2. I want to get at the x. What do I have to get rid of now? The cosine. How do I get rid of cosine? I cosine inverse 0.212. But first, is cosine positive or negative in this situation? Negative. Where is cosine negative? All students take calculus. Second and third. It's all coming back to you, right? No. All students take calculus. So therefore, all of the trigonometric functions are positive in the first. Cosine is positive in the fourth. So therefore, cosine is negative in the second and negative in the third. See it? Okay, so we know where cosine is negative. So what I'm going to do is I'm going to cosine inverse 0.212. And what do I get? I get 1.357. Am I in? We should be in radians. Just want to make sure I've got this. Yes. Okay, we're good. All right. So I've used up the negative as I've determined my quadrants. So when you do the inverse, you don't type in the negative. You simply just type in the positive. I come up with 1.357, 1.357, and 1.357. Those are my reference angles for those spots. Now, in radians, what is this spot right here? Pi, which is, as a decimal, 3.14. So what will I do with 3.14 and 1.357 to come up with this angle? I'll subtract them. So 3.14 minus the answer, and I get 1.78. And then, after that, I take 3.14 and what? I add 1.78. I'm sorry. I take 3.14 and I add 1.357. And I get 4.497. Yes. I want to solve that trigonometric equation. I first determine where it's positive and negative. Where is cosine negative? Second and the third quadrant. Okay. I have to get rid of the cosine, so I cosine inverse. And when we inverse, we come up with the value of 1.357. So what that means is that the radian measurement for this angle is 1.357. And the radian measurement for this angle is 1.357. Well, this radian measurement right here is 3.14. So I have to find that angle there and this angle here. So in order to come up with this angle, I subtract off the 1.357. And in order to come up with this angle, I add on the 1.357. What were the two measurements that we came up with? Now, when we inverse the cosine, we got rid of cosine. What remains? So what do I do to solve for x? Multiply by 2. We've kind of lost our rounding here, and hopefully we'll be good enough. I take 1.78 and I multiply by 2. I get 3.56. And if I take 4.49 and I multiply by 2, I get 8.98. So those are the two values that that should work. Now let's check it out as we look at this. What were my two values I came up with? 4.49 and 8. 3.56 and 8.98. Are those values between 0 and 3 pi? They are. Those are the two values, just like we thought that we would come up with, that we predicted. Okay? Yes. So the period for a sine function is going to be equal to 2 pi divided by b. So in order to come up with f of b, we'll take 3 pi and plug it in. So we got 3 times the sine of 3 pi divided by 2, and we get negative 3. Yeah, so this is 3 pi right here. If you look at the output, it's saying right at negative 3. So if we, I plug in the 3 pi, and it's being divided by 2. And when I take the sine of it, I get negative 1. Multiplied by 3 is negative 3. If you look at the graph, this is the x value 3 pi. What is the y value? No. Nope. So you got two options. You can either plug in your calculator or you can look at the graph. Either way, you'll be good to go. Okay? Question. B is the value in front of the x. So if you have, say this, 4 sine of 2x, that means that the amplitude is 4 and that the period is 2 pi divided by b, or pi. If you have negative 3 cosine of x over 3, then we know that the amplitude is 3 and the period is 2 pi divided by 1/3, or 6 pi. Amplitude is always positive because it's the absolute value. Excellent questions. We should do a trig review, huh? Okay, let's pause, take out your worksheet, and try one of the problems on the backhand side of your worksheet, okay? Take a couple minutes. Okay, here's what I want you to do. Please look at problem number 3 on the front, okay? We're going to go through this together, okay? It says, if you consider this table here, for x is 0, f of x is negative 3, for x is 1, f of x is 3, and for x is 2, f of x is 0. You tell me, does there have to be a value c over the interval 0 to 2 such that the derivative is equal to negative 1 at some point? And you tell me. You go ahead and talk among yourselves. Think about this. See if you can come up with something intelligent to say about this piece right here, okay? Talk. Try to come up with anything. Go. And we would really give these two pieces. We'd say f of 2 minus f of 1 over 2 minus 1 is what? negative 3. And f of 1 minus f of 0 over 1 minus 0 is 6. So what guarantees that we have to have a rate of change of negative 1 during that time? The mean value theorem. On the AP exam, you can write MVT. The mean value theorem guarantees a value C. MTV? No. Does there have to be a value C over the same interval where the derivative is equal to 6? Yes. Which interval guarantees that? The 0 to 1, right? Yeah, so we say f of 1 minus f of 0 over 1 minus 0 is equal to 6. Mean value theorem guarantees C. How about the next one? Does there have to be a value where it's equal to 0? Why? Yeah, because it crossed from positive negative. We could give the same idea, couldn't we? Now, look at these two real quick, and I'll pop up the growl here. Does there have to be a value C over the interval f 0 to 2 such that f of C is equal to negative 2? How is this different than the others? It's not asking for the derivative. Do I have to, between 0 and 2, do I have to have an f of x value of negative 2 at some point? Yes, I do. What tells me I have to have a value of negative 2 at some point? It's not the mean value theorem. It's the intermediate value theorem. The intermediate value theorem says that if I'm going to go from negative 3 to 3, I have to cross over every stinking number between negative 3 and 3, right? Yeah. How about this one? Does there have to be a value C, or does there have to be a value such that f of C is 4? Do I have to get an output of 4? Why? Yeah, I don't cross over 4. If this middle value here was 6, then I would say, well, yeah, sure, I have to cross over 4. Do you see the difference? So when you're and this is definitely an AP type topic and question. I mean, these come up big time. And you trust me here that when we did these type of problems right here, you guys are looking through this one right here, I bet that Carter and Jake could look at their work and reminisce that it was just about 3 weeks ago we were banging our heads looking at the inverse of sine and cosine and solving for our graphs and things like that, weren't we? Yep. And they are examples as I put them in there that we do see on the AP exam. So challenging assignment, continue to putz at it. We'll move on to easier stuff tomorrow. Deal? All right.